test environments management with Docker. I will speak about application environments, I will speak about Docker, I will speak about making our lives easier with Docker. A few words about me. I'm Tomasz Konieczny. I work for Bolder as Senior Quality Assurance Engineer and also as a DevOps. As a QA engineer, I'm responsible for test automation, I mean end-to-end tests mostly. As DevOps, I'm responsible for application environments, from local to production, so Docker, Kubernetes, etc. And this presentation is somehow connected to both of these areas. So let's start. Something that you probably know, I mean automated tests. That's something that is quite common nowadays in projects. Almost every project has some of the tests automated. Why? One of the reasons is to save time in comparison to a repetitive execution of them. I mean, manually executing regression tests takes a lot of time, like hours or even days. And automating it allows us to execute them in, for example, a few minutes. And that's not all, because it can also reduce time needed for the code freeze or for tests before release. And also, automated tests can guarantee us that key functionalities, I mean key for users, are working as expected. But what about automated infrastructure? I've done some research before on previous conversation with this presentation, and it's definitely not that common as automated tests. I mean, is infrastructure really that different that we shouldn't automate it, or at least this test part? Because we still have to prepare at least some basic setup or infrastructure tests. So mainly there were at least a few problems that probably caused it, because configuration of application environments, at least speaking historically, was a bit difficult. I mean, very complex manuals how to configure our application environments. It was possible to automate it in some way, but it definitely wasn't easy back then, I mean before Docker. Also, this task was very repetitive, like regression tests. So it should be automated at least in some way. I mean, every developer, every QA in team has to or needs some local or external environment. And it was possible to automate creating of them using, for example, Ansible, Chef, Puppet, etc. But it definitely wasn't easy. And also, it was really hard to keep the environments consistent. I mean, every team member may have a bit different local environment, like, for example, different libraries, different operating system, or external environments may be even more different than these local ones. So it was, again, very difficult to keep these environments consistent. And also, every change in environments, like, for example, update of libraries, required every person in the team to change their environments, both local or external, like test or production. And that's a place where virtual machines were used quite widely. I mean tools like VirtualBox, Vagrant, etc. that allowed us to create isolated virtual machine with specific software versions, provision it automatically, and then use for application environments. But again, there were multiple problems here. The most significant probably performance. I mean, creating a VM isn't that lightweight thing. So we've got huge, heavy virtual machines that allowed us to create something useful for everyone, I mean developers, QAs, etc. But again, the problem with resources, compute resources appeared. So it was possible to create 1 or 2 VMs, but creating 4 or 5 VMs in one laptop definitely wasn't that easy. And that's where Docker appeared. I will start with some theoretical part because I think it's really important to understand it, because there are key differences between containers and VM's approach, how we should work with that. So what really is Docker? I mean, it's really well-known word currently in IT, but it really is a tool for containerization of applications and for container management. So what are these containers? Containers probably can be explained in the easiest way by comparison to the transportation ones. I mean, in transportation, we use containers. We can put anything inside that it's not really that important what we put inside containers. And then we can ship this whole thing, I mean, this whole package. And we really don't care what's inside. If you look at this picture, there's a huge stack of containers, how these containers are aligned to each other, how they fit, so it's possible to stack them in that way. So about Docker containers. Well, that's a package for application with all needed dependencies. So we pack application and all needed libraries to the Docker container. What Docker gives us here? Well, it's portability. I mean, it's very easy to move containers between environments. Like it's easy to ship containers because it's a standard. It's quite similar in this case. We don't care what's inside, what application is inside. Moving containers between environments is exactly the same. The second one, isolation. From the application perspective, I mean, from the application perspective, it's not important what's outside the container, what operating system or hardware is there. The application is isolated with all needed dependencies to the container, and it's everything that the application needs. Another one, standardization. The containers are standard, so application would work exactly the same on every environment. No matter if it's a local environment or it's production one, the application would work exactly the same. So it's easy to reuse the same setup on both local and external environments. And next one, lightness. Because the biggest disadvantage of VMs was that it was quite heavy solution. So containers are very lightweight. The performance is almost native in case of containers. And performance is like 99% or even 100% of the performance of native solutions. Also, starting container is like milliseconds instead of minutes in case of VMs. But what can we call container a lightweight VM? Well, we really shouldn't, because it's not just lightweight VM. Definitely, containerization is some part of virtualization, but it's definitely not only that. Because we have to work quite differently with containers approach and VMs. Because when we work with virtual machines, we think about system. Like we use tools that allows us to emulate hardware, BIOS, then we install the system, and then we can put application on top of that. In case of containers, we don't think about the system. System isn't that important for us. We don't need that. We don't want to work with system and isolate the system. We need and we want to isolate a specific application and all dependencies. So we isolate specific processes, or at least Docker does it for us, in the host system. It's isolation of processes. So we have to think more about application than the environment here. But what about what's probably most important thing about Docker, and the most important advantage is ease of use. Because it was possible to use containers even years before Docker appeared. But what really Docker gives us is this ease of use, and it was mainly designed for development purposes. So let's start, let's create some container. And here is CLI that maybe isn't used that much because there are tools easier or more convenient to use, but it's probably best to show example based on it. So docker run command allows us to start the container. In this case, we will use adminer. If you don't know this tool, it's like graphical application to manage MySQL databases. And normally you would have to install PHP because it's some PHP application. You would have to install Apache or Nginx or something else, some other web server. And you will have to install it, or maybe you will have some package for your system, but still installation would be needed. Then you will have some changes in your host system. And if you want to use it just once, why to install it, then remove it or forget about it? Well, we can use Docker here. So Docker run command allows us to start the container. And in this case, we will use standard image that is already available. That's in the end adminer latest. Latest is a version. We don't care about the version here. That's not that important in this case. So we would run the adminer image. And the rest of the parameters, -d is detached, so it would be run in background. -p is parameter for port mapping, so we can, in this case, map port 8080 from the container to the host environment, because this application by default would run on 8080 port in this container, and we want it to be available on our host site. The name is our name that we want to give here. In this case, it's just adminer because it's the easiest thing probably. And I've ran this command, and just a few seconds later, I ran the second one, docker ps -a. And docker ps is a command that allows us to check running containers. So in this case, we can see some container ID, image, adminer, uptime status like 8 seconds, created 8 seconds ago too, and also our name adminer. So let's check it in our browser. Localhost 8080, and we can see running adminer application here. So it's working. But what's that Docker image I told you that I used? Well, what is Docker image? Docker image is like a template how to create the container in the binary form. So it's built source for the container. And in Docker, there are Docker registries, I mean repositories for images that we can use. There are official ones created by Docker creators for some popular software packages, like for example PHP, Apache, etc. There are public repositories, like for example open source projects quite often create repositories, Docker repositories for their products. There are also private ones that are used mainly for some internal things that you don't want to publish. And the biggest repository, the default one, is Docker Hub. That's where most of the images are stored. But I told you that CLI isn't that widely used because mainly it's not that convenient. What we really want in case of application environments is infrastructure as code concept, at least some implementation of EAC. What is infrastructure as code? Mainly it's the idea of binding infrastructure to specific application versions and storing that in the repository with application or related to application. So mainly it's about describing architecture like we, for example, write tests or write application. And there is a great tool that allows us to implement this concept that is really easy to use both in development and local tests. This tool is called Docker Compose. I told you earlier that in the case of containers, we try to isolate processes. And there is a very simple rule. We try to isolate only what's necessary in the container. So one container, one purpose. We don't put like few applications into one container. That's not what we want. We need, for example, a container for application, some PHP environment. Well, we create container. We need additional service like MySQL, for example. We create additional MySQL container. And what's Docker Compose? It allows us to describe it in the repository, but it also is a tool mainly used for container orchestration. Because if we have like 1,000 containers, and that's quite common if we have, for example, microservices, we won't start every container with Docker run command. Well, that's definitely not that convenient. So using Docker Compose, we can orchestrate containers, start, for example, manage containers at the same time, multiple containers. So again, some example. Let's assume we have a very complex application visible here, like this index.php. It displays the text, but let's assume it's something more complex, like it's sending emails or something like that. And we have to prepare application environment for that. So we need definitely PHP, we need some web server to serve it, and let's assume it requires specific versions of, for example, PHP. So we have our application, index.php, and we create a specific directory called Docker, where we would put infrastructure-related things. And there is this Docker Compose YAML config file. Docker Compose uses YAML configs because it's quite easy to write them, parse them, etc. And by default, Docker Compose YAML is the name that's used here. The version isn't that important in this example, so start with services. Services allows us to describe containers we want to create. So in this case, we need PHP and some web server, and that's the container for our application. So let's name it app. It's the same name that you saw earlier in Docker run example. We would use image that is available on Docker Hub. It's called PHP 731 Apache. So it's image with both PHP and Apache as a whole. And that's all we need currently for running the application. And also we would map ports 80 to on the container side to the 80 on the host side. So we can use the application on the host machine. And because it's environment for development, we want to also mount specific project directory to the container. So in this case, we map the directory where the application is to the var www.html directory inside container that would be served by Apache in this case. So we can work locally on the host side with our favorite IDE, and it would be reflected on the container side. So it's really everything that's needed for this application to work. But let's assume this application also sends emails, and it's some test environment. We don't want this application to send emails to the external services. So we would use mail catcher here. It's again quite standard software, but it's very useful to put it also into the application setup. So again, name mail catcher. Image that's also from Docker Hub repository, and we would map port the 1080 to 1080. That's the port where this application is running inside the container. We would map this to the host side, and again we would have to run it. With Docker Compose, it's a bit easier because it's just about configuring the application environment once in the repository, because it would be in the same repository as the application. And the rest of the team would only have to execute one command to set up whole environment needed by the application. So I would execute just the command docker compose app. Docker Compose would do everything for me. I mean, create some default network that's used for communication between these containers. It would set up also the application container, the mail catcher run. We can now check in the browser, localhost 80, where the application is working. So the setup is working as expected. What are the advantages of this approach? Well, we have dependencies in specific version. I mean, PHP, it was 7.3.1. Specific version needed by application. Achieving this in case of normal setup, not container-based, would be a bit difficult, because every developer may have quite different versions of libraries or different operating systems. Also, external environments may be a bit different. So it definitely won't be that easy in that case. And here we have just set up in our repository that everyone may start very easily with specific needed versions. What is really important here is that we don't have any changes at the host side. So if we don't need the container anymore, we just remove the container. We don't have anything changed on our host side. And also advantages of infrastructure as code. I mean, the configuration is something that we have to do just once. And then everyone in team may use it in a very easy way. Also, the problem of environment consistency is solved here because the setup is described in the repository. It isn't possible to have any differences here. And also, it's really easy to start new environments, like it's just executing one command if we have Docker and Docker Compose installed. What it means to us, I mean QAs, is that we can start tests earlier in development process. Because setting up a new environment is that easy that we can set up in like a few minutes, build the application there. We can also test locally. We don't have to push application to some external environments because Docker guarantees us that every environment would be compatible, that application would work exactly the same in different environments. But let's assume that now we have to change the PHP version. Like, for example, we've done some changes in application that requires newer version of PHP. So in classic approach, everyone would have to update their PHP version of their system or download new heavy virtual machine. And in the case of Docker and infrastructure as code, well, it's just about changing the image we want to use. There is image of newer PHP version available in Docker Hub. Well, we just change one line in our Docker Compose YAML file. Then we run Docker Compose up. Docker does everything, will do everything for us. Will replace this container that's not up to date now, and the application environment would be ready. And also, the people who would still use the older version of application, I mean, for example, different feature branch, where it's not needed yet, would still have this old version. If they check out to different branch with newer one, they just run again this command, Docker Compose up. It's again updated, changed to the version matching the config files. But Docker isn't only about using images that are already available. It's more about building custom images. I mean, we can use any existing one and build something on top of that using layers. And that's why I told you that one container should be used only for one purpose. Because when we use a container for a specific purpose, we can then build on top of that. And images are configured or described in the file called Docker file. So here is the example of Docker file. That's the same application as earlier. Docker Compose is almost the same. I will show differences later. But about Docker file. We can build layers on top of any existing image. And because in this case, PHP 7.3.2 Apache is almost okay for us, we just want to slightly modify it, then we would use this image as our base image. I mean this from keyword. That's the image we would use to build on top of that. Then we have run commands. In this case, for example, let's assume we need rewrite a module for Apache, we need Git, and we need one of the PHP things called Composer. I mean the package manager for PHP. Using run command, we would just execute the command, Apache command that would enable this module, A to N mode rewrite. Then we would install Git. Why it's apt-get here? Because, again, this PHP image is based on Debian image, so we can use any Debian software here. So we would install Git. Then we need to install Composer. So basically we could download just the binary from the Composer website or install it in any other way. But what Docker allows us to do is to reuse anything from the ready images. So there is an image called Composer where this binary is available. We can copy files not only from host site to a container, like with classic copy command. We could also copy the specific file from other image. So this last line, from image called Composer, we are copying the Composer binary to our image to create something that we need. And about the Docker Compose file, there is just a small change here. Instead of image, where we defined the image we wanted to use, we used build keyword here. So we are showing which Docker file to use, and also which is the context. I mean, context is the main directory of the application here. And when Docker Compose sees build keyword, then it knows to build the specific Docker file to the image instead of using the available one. But that's not limited to it. We can even specify targets that we want to use. For example, we have a case we have to create different environment types. Like we, for example, have a development environment, and we want to create the test one. Let's assume that the development one is almost identical to the previous one. But QAs need, for example, some different application installed there. In this example, it's Nano, which is a text editor. Let's assume that it's something really important for QAs. And there is change in the first line. It's not only from PHP and some version there, it's from PHP as, and that's our name of the image. So we create image called app.dev, like application for development purposes. But then we can reuse this image that we created. That's the second from instruction, from app.dev as app.test. So we can reuse this image that we described in the beginning, and we can create another image based on it, this app.test, where we would just create another layer on top of this specific image. And in Docker Compose, it's just one other keyword called target, when we can define the target we want to build from the Docker file. And really, it allows us to very easily change environments in the way we need. For example, developers are able now to use their target, and QAs can very easily create other environment based on it. It's just about changing this target. But changing target isn't the thing that we want to do, because that's not why we used infrastructure as code to then change anything in the config files. So it's also possible to use layers on the Docker Compose side. So Docker Compose allows us to build on top of other configs. So that's this old one on the left side. That's the application container, mail catcher. And for example, we are writing automated tests, in this case in Python, and we also need Selenium. So we can create another Docker Compose file. Let's name it Docker Compose test, and define these services there. So in case of Selenium, it's just using the standard image that's created by Selenium project. It's named Selenium Standalone Chrome that provides us Selenium, Chrome browser. Everything is configured there for headless execution. We can use it very easily. And the second one is, again, just standard Python image, like Python 3.7.2. And that's where we would execute our tests. And again, there is a volume keyword at the beginning. We want to mount our directory tests on the host side to the container, so we can still develop our automated tests on the host side, and it will be reflected on the container side. And Docker Compose allows us to choose which config file to use. The default one is Docker Compose YAML, but we can set any config we want with a -f parameter. And as you can see here, it's also possible to set multiple config files here. So in this case, Docker Compose would connect both of them. So the first layer would be Docker Compose YAML, that one on the left. And because of the second parameter, it would also add to it this second one on the right. So if QA executes a command like that, I mean -f Docker Compose YAML, -f Docker Compose test YAML, then QA would receive an environment with both application, mail catcher, and these things on the right side, like Selenium or Python. But in the case the developer only want application and mail catcher, then developer can execute Docker Compose app, and it would start just the environment for development of application, not this test part. And what's really great here, we can even replace some of the parameters using additional layers. For example, if we add on the right side, again, app, build, target, and we change target there, we would be able to replace target in specific config file. And it's very widely used in different environments. For example, there may be some config specific to development environments, like for example, PHP in debug mode or application in debug mode, and then we can create a layer on top of that with different config files, for example, production ones. And that really simplifies the management of environments, because in the very easy way, we configure what we need and then push to the repository, and everyone can use it and with just very simple Docker Compose comments. But what's really interesting here, after like 4 years of using Docker, there is a thing I've noticed. When we started to use Docker or mainly infrastructure as code concept, it really reduced the amount of documentation we need to have. So earlier it was like tens of pages sometimes to document our application setup. Currently, mainly whole documentation is in our repository as Docker Compose files. So mainly it's self-documenting, and our manuals are reduced, like to instructions, install Docker Compose if you don't have them, and just run the application using Docker Compose. Then the configuration application, but it's other part. So that's all probably. Do you have maybe any questions? I'm not sure if it's not working or if there aren't any questions. So that's probably all. Thank you.